today we're going to be looking at combining like terms. To start with, we want to make sure that we've got some common vocabulary as we go through these things. So first off, we're going to start with term. A single number or variable is what that's supposed to say. Or the product of numbers and variables, product being two things that are multiplied. Each term is separated by a plus or minus. So each of these, 3x, 6y squared, or 6y to the second, and I'm going to go with negative 4x to the third. Those are all terms. I'll talk about why I circled that negative in just a minute. Coefficient is the number being multiplied by the variable. So the coefficient here is going to be 3. So 3 is a coefficient because it's being multiplied by x. 6 is a coefficient because it's being multiplied by y squared, and negative 4 is a coefficient because it's being multiplied by x to the third. By the way, if I interchangeably say y squared or y to the second, those are the same thing. Y squared seems to feel like the shorter way to say it, but they're the same thing. Finally, or not finally, an exponent is the small little number to the right, the upper right of a base, and I'll talk about the base, that tells us how many times we multiply the base by itself. So what this is telling me, talk about the base at this point, y is the base here, and this 2 right here is telling me that I need to multiply y by itself twice. The base over here is x, and this exponent of 3 is telling me I need to multiply x by itself 3 times. So another way that I could write this middle term is 6 times y, and minus 4 times x, times x, times x. So notice I'm not adding or subtracting within these terms here. That's only happening between them. So now we have some common vocabulary to move forward with. Let's take a look at some like and unlike terms. So like terms, what we specifically mean about them is that the variable and the exponent are exactly the same. So if I look at this term right here, 3x squared, then I need to look for any of the other x squareds. The 4x doesn't have the squared with it, so that's not a like term. This is 6x to the fifth. The exponent is different, so that one's not the same. Negative 5x squared, I'm going to go ahead and, if it'll let me move that up here, I've also got a 6x squared, so I'm going to group that together as well. So all of these are like terms. Negative 9 doesn't have an exponent or a variable at all, and so I can only group it with other constants. And that was one of the terms I did not talk about. A constant is just a number. So we've got 10 over here, got 8 over here. I'm going to go ahead and move those all together. So we've got, those are all like terms. Let's take a look at this 4x here. I've got 4x. Let's see. Got 4y, but it's not the same variable, so not a like term. I've got 8xy. Again, xy is not the same as just x. So the only other just x I have is this x by itself. Remember, x and 1x are the same thing. So I can write a 1 with that if that makes me feel more comfortable with it. Let's see, I've got 6x to the fifth. That's kind of its only one. I don't have any other x to the fifths. I don't have any other xy's either. I do have a few m's, so I'm going to put those together. And this These guys are kind of all by themselves. They don't have a like term to combine with. And we'll talk about what to do with that in just a minute. These are all like terms. Another thing I want to talk about, I'm going to write this all out as some ridiculous expression in a few minutes, but another thing I want to talk about is I want you to notice that these negatives traveled with their term. So this is a -9. It might have been written as -9, but that's the same thing as adding a -9. Anything here that doesn't have anything in front of it, it's implied that we're adding that. So if I want to write this first group, the m's, 5m plus 5m plus 12m, think about it as having 5 milkshakes and 5 more milkshakes and 12 more milkshakes. The fact that it's a milkshake doesn't change. It's just how many of them I have. So 5 plus 5 is 10, plus 12 is 22. So this is going to be a total of 22m. That's combining all those like terms. The variable and its exponent don't change. It's the coefficient that changes. On the x's here, I've got 4x plus 1x, or just x. That's going to give me 5x. Over with the the x squareds. I'm going to write the positive ones first. Actually, no, I'll just write them out. So -5x squared plus 3x squared plus 6x squared. Now, something to note on here is that it's only the x being squared. Think of this as just like a box. This is a box, this is a box, this is a box. So if I have -5 plus 3, that's going to give me -2, plus 6 is going to give me +4. And you can add in any order, so you can add the positives if you want. So you have 6 plus 3 gives you 9, minus 5 is going to give you a +4. And if these x squareds all represent just a box, then it's going to be 4 boxes. So 4x squared. I don't know if any of my little metaphors are helping at all, but hopefully. -9 plus 10 plus 8. -9 plus 10 is 1, plus 8 is going to give me 9. So those all add together to give me 9. Pardon me. And here again, I can't do anything with these except for just drop them down and put them with my overall expression. So I'm going to write in no real important order. We can talk about order later, but my m's, so 22m, I'm going to cross it off so I know I have it, plus 5x, cross it off, plus 4x squared, cross it off, plus 9, cross it off, plus 4y, cross that off, plus 8xy, cross that off, plus 6x to the 5th, cross that off. So I've got all of my terms accounted for. Like terms have been added. So that's combining like terms. The next video is just going to have some examples of that.